But here we go. Rules of logarithms. There are three basic rules for logarithms. Reminder before we start that, reminder of what a logarithm is. A logarithm is simply another way of writing an exponent. So log base 2 of 8, if I ask you to perform this operation, you're simply saying 2 to what power is 8. That's all that is, which we know to be 3. Or if it's something that you don't know, we also went over yesterday, and I want to remind you of it as well. We went over what we called a change of base formula, to where if you wanted to type this in your calculator, you can by just doing log of 8 divided by log 2. And you can use log base 10 or log base e there to type that in. So that's all a logarithm is. Now your three basic rules of logarithms. Rule number 1, we call it the product rule. If you ever have the logarithm of two things that are being multiplied, and I do this with log base 10, but this works with log base e, log base 5, log base 7, it doesn't really matter. The log of two things being multiplied, you can split this, and that's what all these rules are about. We can split this. Okay, product rule says the log of something times something can be split into the log of the first plus the log of the second. So a product can be split into the sum of two logarithms. Log of 8x is log of 8 plus log of x. The log of AB is the log of A plus the log of B. Again, that's your product rule. Second rule is your quotient rule. And if you understand the product rule, you probably can figure out what the quotient rule is about to say. To divide two things, the logarithm of two things that are being divided can be split into the log of the top minus the log of the bottom. So the log of A divided by B is the log of A minus log of B. And then finally you have what we call the power rule. The log of something to a power, log of x squared. The power rule says if you have the log of something to a power, that you can take that power, and this one's actually really useful. You can actually take that power and move it down in front of that log. So the log of x squared is the same thing as 2 times the log of just plain x. The log of a to the b power is b times the log of a. So the log of anything raised to the power can be moved down front. So again, let's work some problems with those. We have first example. This says write each expression as a single logarithm. We want to split it up, or excuse me, it's split up and we want to combine them. Log base 3 of x plus log base 3 of 6. From your very first rule, your product rule, we're working these backwards. Log 8 plus log x was equal to the log of 8x. Log base 3 of x plus log base 3 of 6 can be written as a single log by multiplying. We can work it forwards or backwards. Why did I put the 6 first? Just because 6x looks better than x times 6. So anytime you have the log of a product, again, you split it into the log of one plus the log of the other. The same thing applies if you have multiple logs being added. It doesn't have to just be 2. You have the natural log of 3 plus natural log of x squared plus natural log of y. And again, the bases don't matter, as long as they're all the same bases. The last one's log base 3. This is log base e. So natural log of 3, natural log of x squared, natural log of y, all of them are being added. So we can apply your product rule and call that the natural log of 3x squared y. Because again, if the log of things being multiplied can be split into the addition of separate logarithms. Okay, next problem, log base 3 of 24 minus log base 3 of 4. Again, the subtraction of logs goes up, and that's your second rules of logs. Log of something minus log of something is equal to the quotient, or the quotient is equal to the difference. So we can actually write this as the log base 3 of 24 over 4. Log of the top minus log of the bottom. And go one more step. Log base 3 of 24 over 4, just reduce that 24 over 4. Never leave it as that division if you can actually divide it. That'd be log base 3 of 6. And sometimes you might come out at the end to where that might be something you can evaluate. You could say 3 to what power is 6? It's not 2. 3 to the second power is 9. 3 to the first power is 3. That's going to be somewhere between 1 and 2. You could evaluate that if it were to ask you. You can type that into your calculator. We don't have to on this one. You could use your change of base formula, log 6 divided by log of 3, but they don't ask you to actually evaluate on this because technically you don't even know the log. You don't even know the change of base formula yet. I gave that to you early. It's in this section. That's the reason it makes this section a little bit easier because we don't have to cover that. Log of x to the 6th minus log of x to the 2nd. Again, the subtraction of logs can be written as a quotient. That'd be x to the 6th over x to the 2nd. And always remember to reduce if at all possible. Natural log of x to the 6th over x to the 2nd. Back in the first chapter when we talked about rules of exponents, x to the 6th over x to the 2nd will be x to the 4th. It's kind of fitting, while you're writing that down, it's kind of fitting that this is actually in the same section as these rules of logs, because the rules of logs actually follows the same pattern as this. Because again, a logarithm, think about it, a logarithm is simply another way of writing an exponent. Why can you do, when you're dividing, why can you do the subtraction thing that we're doing? Well, how do you do this? This is division of exponents. What do you do to divide two exponents? You subtract. What do you do to multiply two exponents? What if I ask you to do like x to the 3rd times x to the 4th? To multiply two exponents, you add. Logarithms are exponents. That's the reason the rules for logarithms applies directly with the rules of exponents. The next one says rewrite each expression in terms of log base 3, or log of 3, excuse me. They don't want log 3 to the 8th. They want something that just involves log of 3. Log of 3 to the 8th, just a reminder that 8 can be moved out front. So if you knew what the log of 3 was, and you want to know what the log of 3 to the 8th power is, just multiply by 8. It's the same thing. Log of, a little bit of a review here, log of root 3. If I tell you, again, that the log of 3 is about, let me type this in my calculator. I'll just tell you, the log of 3 is about 0.4771. And all you have is a basic calculator. But I'll tell you that this is true. Then how can you find the log of the square root of 3? By using these rules of exponents. How could I find log of 3 to the 8th power? By doing 8 times that. How do I find the log of the square root of 3? Okay, square root of 3 is the same thing as 3 to the 1/2 power from previous lessons. That 1/2 power can be moved down front, so that'd be 1/2 log 3. So if you know what the log of 3 is, it's up here, then how would you find the log of the square root of 3? You'd take half of it. It would be like 0.236 something, 239, somewhere around in there. How would you find the log of 1/3? Okay, a little bit tougher now. I want to write this not in terms of log of 1/3. I want log 3 stuff. 1/3 is the same thing as 3 to the negative 1 power. You start doing a lot of that. Since we're pretty comfortable with the rules of exponents, 3 to the negative 1 power, if you bring that down to the bottom, that's the same thing as a third. Log of 3 to the negative 1, well, since you have an exponent now, that exponent can be moved down front. That's negative 1 times log of 3. So the log of 1/3 would equal negative 0.4771, because log of 3 was that 0.4771. So the log of 1/3 should be negative 0.4771. Okay, you have two inverse rules that actually follow directly from the rules of logs that we just covered. And here they are. Log And I'm going to put some numbers in here just because it looks better than the formulas do. If you ever have a log to where the base of the log and the argument is the same, but notice it's being raised to a power. Log base 3 is 3 to the 4th. I'm going to work these out the long way, and then you're going to discover the shortcut. Anytime you have a power, again, that power can be moved down front. And log base 3 of 3, 3 to what power is 3? This would be 1, so this is simply 4 times 1. Log base 5 of 5 to the 7th power. Exponent can be moved down front. That's 7 times log base 5 of 5. And again, log base 5 of 5. 5 to what power is 5? This would be 1. 7 times 1 is 7. Log base 10 of 10 to the 5th power is 5. Log base 6 of 6 to the 8th power is 8. Log base e of e to the 10th power is 10. So your first inverse rule, if you ever have a log where the base and the argument is the same number and there's an exponent, the answer is going to be your exponent every time. That's your first inverse rule. So again, log base 3 of 3 to the 100th power is 100. Okay. The second inverse rule is not as easy to see, but I bet you can guess the answer already. 5 raised to the log base 5 of 3. Your second inverse rule, here's how we're going to do it. I don't know what this is. The first time I work through this is going to be kind of your proof of why this works the way it does. I'm going to try to figure out what this is equal to. So I'm going to say equals x. I don't know what it is. Let's, from yesterday or the day before's lesson, let's change forms now. This is in kind of an exponential form because you have something to a power equals something. Like 5 to the 10th power equals x. How would I change form? That'd be log base 5 of the number on the other side is equal to the power. And look what happens when you change forms. It looks like those equations you solved yesterday. Log base 5 of x equals log base 5 of 3. Oh, x must be 3. So this stuff must equal 3. Let's do another one. 4 raised to the log base 4 of 7. If I ask you to clean that up, hopefully from that first problem you already know what the answer is. If you're raising a number to a logarithm with the same base, that's this scenario. I don't know what the answer is. Change forms. Log base 4 of the number on the other side is equal to the exponent. The only way log base 4 of x could equal log base 4 of 7 is if x is equal to 7. So this stuff cleans up to equal 7. So 10 raised to log base 10 of 9 is equal to 9. 7 raised to log base 7 of x is x. 4 raised to log base 4 of 12 is 12. E raised to the natural log of 6. That's the same type problem. The base e is raised to a log of base e. E raised to the natural log of 6 would equal 6. That's your second, and they call them inverse rules. They're basic rules. If you ever run up on a log with the same base as argument, with an exponent, the answer is the exponent. Or if you ever run up on a number being raised to the log with the same base of the argument, then your answer will always be the argument. Okay. A few more problems just to practice, and like I said, we're finished. Okay. These next problems are, to me, they're kind of like puzzles. What they're going to tell you is they're going to tell you what the log of, let's say maybe you know the log of 2 and the log of 3. The log of 2, again, that's 10 to what power is 2, 10 to what power is 3. We know the log of 2 is this, and log of 3 is this. We can actually, using our rules of exponents, we can change things. Let's see, the first one's a log of 6. We can actually use these two logarithms to find this logarithm, using your rules of exponents. By somehow splitting 6, we're going to, again, somehow write this in terms of these two. And I think that's the way they're going to word it on your homework, is rewrite this in terms of this and this. Such as, I know that 6 is 2 times 3. So I can rewrite the log of 6 as the log of 2, because again, 2 times 3, that's your product rule, plus the log of 3. So if I wanted to find the log of 6, it's the log of 2 plus the log of 3. You can add this decimal with this decimal and give an answer. That makes sense. Like I said, they're kind of like puzzles, because you've got to figure out how in the world can you turn the second one is 16/3. How can you turn a 16/3 into 2s and 3s? Well, first off, it's kind of obvious. This is being divided. So that'd be the log of 16 minus the log of 3. And I already know what the log of 3 is, so that's 0.4771. But what in the world could I do with the log of 16? How can I turn 16 into 2 stuff? Or 2 stuff and 3 stuffs? Because 2 times 2 times 3, that's 12. 3 times 3 is 9. 3 times 3 times 3 is 27. Using products or quotients, I need a 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. This is actually 2 to the 4th power. And from your third rule, the log of something to a power, I can just bring that power down front and change it to 4 times log of 2 minus the log of 3. So if I want to know what the log of 16/3 is, 4 times 0.3010 minus 0.4771. And that would tell you the log of 16/3. The third one we've kind of already done. The log of 1/3, I'm just going to go over it again. That's a 1/3. That would be the log of, the easy way would be the log of 3 to the negative 1. I want to work this one different though, because a lot of you are going to do this. You're going to see the log of 1 over 3, and you're going to do the log of 1 minus the log of 3. And you're going to say to yourself, I know what the log of 3 is, but I have no idea on how to find the log of 1 because it's not listed up here. But if you go back to the rules we talked about yesterday, the log of 1 is saying 10 to what power is 1. Whether it's base 10, whether it's base 7, whether it's base e, anything to the 0 power is equal to 1. So this would be 0 minus log 3, which is simply the negative log of 3. And I will write that one down. That would be negative 0.4771 if you were to type it in your calculator. The easy way, again, to have done that was to rewrite 1/3 as 3 to the negative 1 power. Bring the negative down front. That'd be negative log 3. It'd be the same answer.